In this little video, we are going to talk about factoring. And all we're going to discuss is we're going to describe what factoring is. And then we'll take a look at some useful applications of factoring. That is, well, why do you need to know how to factor? How can it help you out? This video is not going to show you different factoring techniques. There are a couple other videos that you can look up that will help you with that. But here we're going to get an idea of what factoring actually is. So to begin with the definition, factoring, we'll call it breaking apart a mathematical expression into parts that are joined by multiplication. So if we have something that is a mathematical expression and we see addition and subtracting joining the terms, factoring is a way of changing the look of that expression to put some brackets back in so that now you have terms that are multiplied together. So let's take a look at a couple of examples. So let's say we had a mathematical expression and it was just 2x times 3x plus 5, let's say. Well, we know that this is a monomial times a binomial, and if we were to multiply this out to remove the brackets, we would take the 2 and we'd multiply it into the brackets with 2x times 3x is going to give us 6x squared. And then if we took the 2x and we multiplied it in by the 5, well, that would result in plus 10x. Okay, well, we know that this process of multiplying into brackets and removing the brackets, well, that would be typically found in a question where you were asked to expand. And you might have a question that says expand and simplify, the simplify part being collect some like terms at the end if you can. Okay, so that's expanding. Well, factoring is just doing the opposite. If I wanted to then factor is going to, or factoring, is going to start with an expression that looks like this, and it's going to look to replace that and put brackets back in and join things by multiplication. So we're just going to go in the opposite direction, and in this case, I could use the technique of common factoring, and I could look at the 6x squared and the 10x, and I can say, well, what do they have in common? I can clearly see that they both contain an x, all right, and they both are even numbers, so they must be divisible by 2, and in fact 2 is the greatest common factor between 6 and 10. So if I was to pull those two things out, common factor out the 2x, what I'd be left with inside the brackets is 3x, and then the 10x, when I divide that by 2x, I would be left with 5. And you can see that we're back where we started. So common factoring has allowed us to take a mathematical expression that is joined by addition in this case, and we have turned that into a mathematical expression that has terms, but this time they're joined by multiplication. Okay, and that's what factoring is. It's the opposite of your expand and simplify questions. It's just going in reverse, and it's saying, let's put the brackets back in, and let's put it back in a form that had terms being multiplied together. Well, why would you want to do that? What is the sort of the intent of putting multiplication back in? Well, let's look at a couple of examples. So why use factoring? Well, if we had a question, and we'll just put a quick one here. If we had a question that looked like this, we said 3x squared plus 15x and plus 12. And we said divide that by 3x plus 12. And tell me what that answer is. So if it just said simplify this, could you make this a little simpler? Well, some of you might come along and say, aha, it looks like we've got a 12 that looks to be on the top and the bottom, and we've also got a 3x on the top and the bottom. So some of you might take this approach. You might say, okay, well, wait a minute. 12 cancels with 12, and the 3 cancels with the 3, and we can cancel this x with one of these x's, and we're left with x plus 15x, and there we are, all nice and simplified. And that is totally way off track and incorrect. Okay? What you have to be aware of is that we cannot cancel when terms are joined by addition or subtraction. You are not allowed to do that. The only way that you could ever cancel a fraction, top and bottom, is if the terms are joined by multiplication. So factoring is going to make our lives really easier here. If I was to factor the top, and again, we're not going to show you how to factor here, just this is what factoring is used for. If you want to learn how to factor, just take a look at the other videos. So this top, well, first thing I can realize is that, you know what? There's actually a common factor of 3 in all of these terms. So if I was to factor out a common 3 out of the top terms, well, I know that 3 goes into x squared. Well, x squared would be left inside, and then plus 5x, and then plus 4. So that works out really well. And lo and behold, on the bottom, both of these terms also share a common factor of 3. So I could do the same thing to the bottom as well. I could say, well, wait a minute, there's an x, and then plus 12, that's going to be plus 4. And notice that I've created two terms, 3 times everything in the brackets on the top, joined by multiplication. And on the bottom, 3 times everything in these brackets. It would be completely valid now to go ahead and cancel these two 3's because they are joined with another term by multiplication. Okay, are we done yet? No, we're not done. Because if we look at this top here, I can clearly see that this is a quadratic, and it is going to actually factor into two binomials. This can factor into x plus 4 times x plus 1. Now the bottom just has x plus 4 remaining. Okay, well look what's happened to the top. I now have two terms in brackets joined by multiplication. And because they're joined by multiplication, now I can come along and I can say, all right, this bracket will cancel with this bracket. Perfectly legal because of the multiplication. And that means this entire expression has been simplified down to x plus 1. So factoring is a very useful technique when we're asked to simplify mathematical expressions, because once we get things joined by multiplication, then we can start our canceling. All right? If they aren't joined by multiplication, you cannot cancel. So just remember that. You must introduce brackets and get things joined by multiplication before you cancel. So that's one use of factoring. Well, what's another use of factoring? Well, if we consider that we had, let's say, a function, and the function was f at x equals x squared plus 6x plus 5. And I asked you, okay, can you tell me where that quadratic, and I know this is a parabola because of the degree 2, the x squared. I know that it opens up because the value in front of the x squared is 1 and it's positive. If I was to ask, where does this cross the x-axis? That is, what are the x-intercepts or the roots of this quadratic? Well, if I wanted to find the roots, I could say, well, I know that's going to occur when the y value, or the value of this function, is 0. So I could substitute a 0 in there and ask the same question. When does x squared plus 6x plus 5 equal 0? Well, I don't know. I have no idea. How do I solve this? Well, I could do a couple of things. I could do a bunch of guessing and checking. I could just start substituting x values in randomly, hoping to find a right side that equals 0 and say, oh, I found one, there we go. And that's only going to be very helpful if this doesn't cross the x-axis at some sort of fraction. You know, if it crosses as a nice integer value, we might be able to find it through trial and error. But if it's crossing at a decimal value, we might be searching for quite some time. So how can factoring help us here? Well, if I realize that this right side, this quadratic, actually factors, it's a simple trinomial, and it's going to factor into x plus 1 times x plus 5, I now know that I have two terms in brackets multiplied together, producing an answer of 0. Well, the only way that that can happen, if you had two mystery numbers, two values you didn't know, and you said, when I multiply these two values together, I get an answer of 0. Well, your response should be, well, you know what? One of them has to be 0. So if we take a look at this term here, for x plus 1 in brackets to equal 0, well, that's true when x equals negative 1. And if I look at this other bracket and ask the question, well, when is x plus 5 equal to 0? Well, that's true when x equals negative 5. So very quickly, I have been able to find out some information about this quadratic. And if I was to sketch this really quick, well, I'd pull out a couple pieces of information. The first one is I'd realize that this 5 on the end of standard form, well, I know that that is the y-intercept, right? So I can put a dot there, and we'll do it in blue. So there's I know the intercept is going to be there. But now I also have the two roots. I know where it crosses the x-axis. So when y is 0, x could be at negative 1. So we'll say right there. And when y is 0, it might also be at negative 5. Let's assume that's right there. So there's the negative 5, and there's the negative 1. And that means that generally the shape is going to, just a quick little sketch, it's going to, go down there and up like that. And that gives me some information about that quadratic. So factoring and the ability to change a mathematical expression to reintroduce multiplication makes simplification of mathematical, especially rational expressions, really easy because we can cancel the top and the bottoms when we have multiplication. And it also helps out when we're trying to do things like find the roots of a quadratic very quickly. If we use factoring to put the brackets back in, now we know that when we multiply two values and we get an answer of 0, one of them could be 0, and so it makes the solution very easy. Okay, so factoring, a really useful tool, and this is why you need it. And if you take a look at the other videos, you'll see some different factoring techniques that show you how to go ahead and do factoring.